Hello everyone, welcome to GeekNerd. Today we are going to solve three sum closest problem, which is the 16th problem of array. And this is the 16th problem. And if you want this GeekNerd HDC, then you can check out the description, and there you will find a link. You can click and reach this website. And here we have the array. We have 18 problem of the array, out of which 15 problem is solved. Now we are solving 16 problem, that is 3 sum closest problem. So and previously we have solved 15 problem, and if you want to see the solution of it, then you can click over here and see the solution of it. Okay, but as we are going to solve the 16th problem, so I will click over here and click the question. Okay, so today we are going to solve the 16th problem. So let's read the question first. So here this is the 3 sum closest problem. So here we have the first we read out the question. Given an integer array nums of length n and an integer target, find 3 integer at distinct indices in nums such that this sum is closest to the target. Return the sum of the 3 integers. You may assume that each input would have exactly one solution. What is saying that we have given a array of nums of length n, and we have an integer target also, and we have to find 3 integer in the array. When we sum it, we'll find the closest to the target. Okay, and we'll have to return the sum of the 3 integer. Okay, and it is saying that like we have only one exact solution. Okay. So here for example, let's understand this question by example also. Here the nums is given -1, 2, 1, -4, and target is 1, and it is the answer is 2. How it is 2? Like if we add -1, 2 and 1, then we are getting 2, which is more closest than the target value. If we calculate any other pair, then we'll not find closer than the 2. As we let's take an example like 2, 1, -4. Okay, so 2 plus 1, 3, -4, -1. If we see the difference between -1 and 1, that is 2. But if we see the difference between 2 and 1, that is 1. So that's why we have answer as 2. Okay. For example, let's see the example 2 also. Here we have 0, 0, 0, and target is 1. So of course, as we have 3 number in the arrays, the only one pair is the 3 number. Then 0 plus 0 plus 0 is 0, and we get closest number as 0. Okay, so the constraint is the length of nums, the array's length that is given is greater than 3 and less than 500, and other things are as normals. So let's see. I'm opening a Excel. Okay, so let's understand this question. First, I will copy this. Hmm. So here we have -1, 2, 1. So what we can do for this question, like we want to find the closest sum of three indices that is closer to the target, right? We have to find the sum of three integer in the array that is closest to the target, and the target is 1, right? Here for the target is equal to 1. Okay, so we have to find the sum of three indices, and like we have to calculate the sum of every three number in the array, and whichever is closest to the target will return that. So for that, what we can do is we'll find every possible pairs. So here we can say that minus 1 to 1 is one pair, minus 1 to 4 is one pair, 2 1 minus 4 is one pair. I think this is all. Like this is covered. These three are covered once. This three is covered once. Okay, minus 1 1. Okay, minus 2 complete. This 2 is fixed. Okay, then we fix this 2. Okay, there is one more also. We can have like this also. Hmm? Hmm? Hmm. Okay, it's covered. Okay, this is all the bits. Okay, so so here if you calculate this sum for this, it is 2 minus 1 plus 2 plus 1, that is equal to 2. If you find this calculate this sum, then it is 5. If you calculate this sum, we'll get minus 1. Calculate, then it will become minus 4. Okay, this is the pairs that we get, and this is the sum of the pair. Now we'll see how much it is closer. So how can we find it? So for find the closeness to the target, what we can do is target minus sum ka mod. So that will be 2 minus 1 mod, that is equal to 1. 5 minus 1 ka mod, that is equal to 4. Okay. Then minus 1 ka mod, that is equal to 2. Minus 4 minus 1 ka mod, that is equal to 5. So which is smaller? This is the smallest, right? That means this one is the closest pair, and the sum of it is 2, so we are returning 2. Okay, getting it? So what how should our code look? So for this we have to find every pairs. So what we can do, we can have a nested loop of we can have three nested loop in each. Okay, so first loop will start from 0 to n minus 1. Okay, second loop will start from j is equal to I plus 1 to n minus 1. Third loop will start from k is equal to j plus 1 to n minus 1. Why we take I plus 1 and why we take j plus 1? Because we don't want to repeat each indices in sum. We don't want to repeat a single indices twice. Okay, so that's why we took this thing. Okay. Then what we'll do, we'll add sum of nums I plus nums j plus nums k. Okay. We get this sum. Okay, then we'll find the closeness. So the closeness is equal to modulo of target minus sum, or sum minus target, whichever, anything is good. Okay, target minus sum or sum minus target. Okay, then because we are doing modulo of it, right? So we have to store closeness in our outside of the, what we say, outside of the loop, so that we can check every time, like, is the closeness is if we do we find a pair which is more closer to the target or not. If you find a a sum that is more closer to the target, then we'll store the sum as a result sum. So we can have result sum in outside also, and another one is closeness. Like, okay, we can say it's a result closeness. We can have that. Okay. It's not a correct term, but okay, we can have that. And we'll initialize it as a max integer, so that whichever we'll encounter first, that will be the closeness of it. Okay. So if we find closeness is less than result closeness, or we can say current closeness. The current closeness, then uh, we'll update the result sum is equal to sum, and we will continue the loop till every pair is encountered. Okay, and at the end we are going to return the result sum. So I'm explaining it again. For finding different pairs of three integer, we have to have a three nested loop. So that's why we took here three nested loops. Okay. So because of that, we can have this type of pairs. Okay. Then I calculate the sum by adding all the numbers that we find in that particular index, and then we calculate the closeness by subtracting target minus closeness and doing modulo of it. Okay. Then we store outside of the loop as current closeness is equal to max integer. So it's a infinite number, or we can say like it's a maximum number that's possible. And if we find any closeness lesser than that, then what we are going to do, we are updating that. So the first closeness that we find will update there, and afterwards it will find the closest one. And in the result sum, we we don't have a number, or we can have it as 0 also, it doesn't matter. Anyways, we are going to encounter it first time here, and we are going to update the sum. Okay, so let's proceed to the platform and write the code. Okay, uh, better to make it big. Hmm. Oh, am I not logged in? Okay, I have to log in. Yeah, it's logged in. Okay, now Now I'm solving this question. Okay. We are going to have result sum comma current closeness is equal to integer dot max value. Then we are going to have three nested loop here. Okay. So what I'm going to do, I'm going to store the size of nums in n, so that every time I'm mentioning n as a length of nums. Okay, so that's why I'm going to do that. And we are going to have j j is equal to 0, is not 0, I plus 1. Then j should be less than n, j plus plus. Okay, then another loop, k is equal to j plus 1, k less than n, k plus plus. Okay, then we are going to have sum is equal to nums I plus nums j plus nums k. Okay, then we are going to find closeness is equal to math.abs, that is the modulo absolute value target minus sum. If closeness is less than current closeness, then we are going to update the result sum is equal to sum, and in the end we are going to return result sum. Why is that? Okay, we have to initialize. So the compiler is like that, like it's not initialized. What if uh, we, the code never goes into the for loop? Then then the result will be nothing, right? So that's why it's throwing a compilation error. But by the way, we'll not get it, but the compilation is not completing because of that. Okay, we are getting a issue here. What is that issue? Target 1, and I'm getting output as -1, but I should get 2. Why is that? Let me see. What did I make wrong? Target is 1 minus sum minus 1 is equal to it should not be throwing error. Okay, let's dry run it. Okay, let's dry run it. It should not be happening. Okay, wait. If I encountered anything, then I will. Result sum should be equal to sum. Whenever we will find the sum of indices, which is going from I plus 1 to that's correct. Okay. Yes, target minus sum, it's correct. Then whenever we find the closeness is less than current closeness, then we are updating the result sum in it. That's all. It is also correct. Okay, let's solve this. Mm, mhm. Hmm. So for this, first the result sum will be 0, right? And current closeness will be max. Okay. So first I will be 0, j will be 1, k will be 2. Okay. And n is actually 4, so it will go up to 3. Okay. So first pair is -1, 2, 1. Okay. The sum of it is 2. Okay. 2 minus 1 is equal to 1. So we are getting closeness as current closeness as 1, which is closeness is less than current closeness. So we are updating it as a 2. Okay. Then we update k to 3. Hmm? So we'll get a pair of -1, 2, -4. Okay. If we see that, then the sum of it is equal to -1 and the closeness is 2. But it is greater than, so closeness is 2, 2. The sum is sum is -1 and the closeness is 2, right? So as the closeness is greater than current closeness, so we are not updating the result sum. Okay, nice. So again the I will increment 1, j will increment no, actually I will be 0, j is not reached to 3, right? So we'll update j again. So we'll update j to 2 and k will be again 3. So 0, 2, 3. So 0, 2, 3 is equal to -1, 1, -4. Okay. So here what we the sum of it will be -1, 1 is equal to, and the sum of it is equal to -4, and the closeness is 5, which is also greater than the current closeness, so we will not change result sum. Okay. Then the I will increment to 1, j will increment to 2, and k will increment to 3. Okay. So 1, 2, 3. So it's like 2, 1 and -4. So here the sum is, we are getting sum as -1 and the closeness is 2, which is greater than the current closeness, so we will not change, and we are returning the result sum, that is 2. Then we should get 2 for this case, but we are getting 1. Why is that? Hmm. Mm-hmm. I have made something wrong, but I'm not able to observe it. Mhm. What did I take here? Target minus sum, right? I also take target minus sum. Okay. Current closeness is less than current closeness. Then only we are going to update sum, right? Okay. Then the last option is let's print it and see what why I'm getting it wrong. Okay. So that is println mm, I j plus k plus sum plus closeness plus current close. Did it. Hmm. So let's print it and see what's the outcome is. Okay. Mm, mm. Oh, okay. Okay. I got it. I got it. What is I'm making wrong now? Here, okay. It's a very silly mistake. Here we are updating the current closeness also, right? So here I have missed to update the current closeness. So okay, that's the error. Okay, my bad. If will not update the current closeness, then every time it will find the same thing, right? So find that the closeness is lesser than the current closeness because the current closeness will be max only. Okay, now it is accepted. Let's submit it and see is it accepting or not. It is accepted. Okay, but is it the best solution? I don't think so because we are using three nested loop here. So the time complexity for it will be big O of NQ. We have different approach for it also. So as you can see, we are using like we are using three nested loop. So it's going like it's very time taking. So what we can do is first we'll sort the array and use three pointer method. So what we are going to do, sorting will you will use the inbuilt sorting method that is internally using the merge sort, which will take n log n. Okay, so let's see. um, let's take the example from here. Hmm. So, so it's a -1, 2, 1, -4, right? Hmm? So we'll sort it like what will be it like -4, -1, 1, and 2. To convert from this to this, it will take n log n. Okay. Then what will we do? We'll have a pointer here. We'll have a pointer here, and have a pointer here. The first pointer I will iterate from the 0th index to the last index. J will point to the I plus 1 index, and K will point to the last index. So what will happen? I will iterate from 0 to n minus 1. J will point, and in that J will point to I plus 1, and K will point to minus 1. And based on the condition, like what is the sum of it, because as we have sorted it, huh? Like let as the target is 1, target is equal to 1. Okay, so -4 -1 2. If we sum it now, so what is it like -4 1 -1 -5 plus 2, -5 plus 2 is equal to -3. So we are getting sum as -3 here. Okay, and the target is 1. So we'll store the sum as -3, result sum is -3. Huh? Result sum is -3. Okay, and the current closeness will be will not store current closeness for now. No, we have to. Okay, we'll have to current closeness store. Current closeness will be um -3 -1 will be -4, and the current closeness is 4. Okay. Okay. And here as it is -3 is lesser than the target. So what do you think? We have to increase the sum, right, to make it closer. Okay. To increase it, so do we have to reduce the k? If we reduce the k, then the one of the element will be decreased, right? So we don't have to reduce the k. We have to increase the j. So that means we will the condition here will be applied as if as the current closeness is 4. So so if we if the sum of the three number sum is less than target, then what we are going to do, we are going to increase the j, because that it will increase an element increase a number in the element. Okay. And if the sum is greater than target, then we have to decrease the k, and we have to do it until j is less than k. Okay. So here um here what we are going to do, we are going to increase the j to this. So -4, 1 and 2. If we add these three, then that will be -1, and the current closeness will be improved to -1. Okay, so if we do the -1, that is equal to 2. The current closeness will be 2, and the result sum will be -1. Okay. By this, what we have improved, like here we can have -4, -1 and 2. Okay. And -4, 1, 2. We have did that. Okay. But we didn't, what we not check is -4, -1 and 1. We have eliminated this one. Why? Because we haven't reduced the k, right? After that, we will move I to this point and will not check -4 again. So we are reducing some iteration in between. And if you check also, so here what will be the pseudocode of it? I will iterate from 0 to n-1. Okay. And there will be a loop, there will be a initialization. J will initialize from I plus 1, and k will initialize as n-1, and we'll have a while loop of j less than k, and we'll have to write the logic inside it. So what we are using two nested loops. So the time and the sorting time complexity is n log n. So the whole time complexity will be n square. So inside of it, what will be the logic? We are calculating int sum is equal to nums of I plus nums of j plus nums of k. Okay. And we are going to have a int result sum is equal to let's have a 0. Okay. If we find, okay, and we can have closeness also, or we can calculate the closeness also. Okay, let's calculate the closeness with the result sum only. So int closeness is equal to absolute value of target minus sum. Okay. And if we calculate the result closeness or current closeness, then that will be target minus result sum. You can do that also. And if closeness is less than current closeness. Okay, ignore the handwriting. I have less space there. Okay. Then we are going to update the result sum as sum, and thus that way I don't have to update the current closeness because we are calculating it every time. So we just have to close it. Let's write this in code. Okay. So we are not initializing outside. Okay. Huh? We are not taking two nested loop inside also. Int j is equal to I plus 1, k is equal to n minus 1, while j less than k will have a loop, and inside of it we'll pull this inside. Okay. In that we are calculating the current closeness inside the loop is equal to math.abs target minus sum result sum. Remove this only. Okay, and I have forgot about one thing. For the increment of I and j, like we are going to have this logic, right? So if uh, sum is less than target, we are going to increase, or we can have like this also, like ternary operator. Okay, for now I'm using loop only. So for if sum is less than target, then we are going to increase j, else we are decreasing the k. Okay, so here also if um, sum is less than target, we are increasing j, else we are decreasing the k. I hope this passed the test cases. Oh, okay, there is a typo. Okay, something is wrong with the test case one. Let's see what is it. Mm, hmm. I think it's there with the current closeness. Okay, so what we can do is we can have the current close initialized only. Hmm. Mhm. Let's see. Okay, still there is a issue. Um, my output is coming -1. Why is that? Mm, 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 mm. Closeness. When the closeness is less than current closeness, we are updating the sum. Then current closeness, we are updating also current closeness. Okay, it's good. We are adding all nums, nums I, nums j, and nums k. Also, we are finding closeness correctly. Also, if the sum is less than target, then we are increasing j, else we are decreasing k. Okay, that is good also, but okay, I'm not able to find what is wrong inside. Okay, so for this, what we can do, we can print. Print. Okay. Mm, I nums I plus nums j plus nums k plus sum plus closeness uh, plus result sum. Let's see. Okay, I missed semicolon. Okay, first we are encountering. Am I going to do that? Okay, nice. So -1, 2, and -4. First we are encountering that. -1, -2, -4. Okay, nice. So we are out of which we are getting sum as -3, and we update the result sum as -3, and closeness is 4. It's better to have current closeness also. Current closeness. Hmm. Okay, huh. And current closeness is also 4. Okay. Okay. Then we find -1, 1, and -4. Okay. Then as we find less. Okay. What's wrong is what's wrong? What did I wrong? Make wrong is first we have to sort this, no? So I haven't sorted. So first we have to sort it. So because without sorting, this logic is nothing, right? So we missed that. So okay, my bad. Let's run it. I hope this time it will run. Okay, arrays dot sort. Okay, and when I submit it, it will pass, and the time complexity of it will be big O of n square. You can see that also. Okay, so I hope you have understood the solution. I have um, stuck in between for this solution. You might have seen me how I debug that problem also. So you can get to know, like, if you face this issue like me, then how can you debug your code also. Okay. So I hope you have understood this question, and if you have any query, then you can comment down below, and if you like the video, then like it, and subscribe the channel. I will It will help me to become like it will help me to motivate me and make this kind of video in future also. So thank you, and meet you in the next video.